All right. So what we're going to do is we're going to start talking about the definition of alternative form of derivative. So alternative. Okay. So this is f prime of c.
It's not showing.
Not showing.
Yes.
How about now?
Okay.
Okay. Definition, alternative form of derivative is f prime of c is equal to limits as x approach c of f of x minus f of c over x minus c. So this is called alternative form of derivative. As opposed of definition of derivative, is going to be f prime of x equal to limits as h approach 0 of f of x plus h minus f of x over h. So what's the difference between two is this is going to give you slope at x equal to c at particular value. So at particular value. So it will find out the slope at x equal to 2, right? So as opposed of this is give you the slope at all x value. So this one's more general. So it covered more ground. It covered more ground, more general. So it can be, if your derivative is 2x, then you can plug in x at any value. X equal to 2, x equal to 3, x equal to 8. It doesn't really matter which x value you plug in. Is that okay? So alternative form is weaker compared to the definition of derivative. But it's called alternative form because you can find slope at particular point. And you need that for certain situations. Not all situations, but you need for certain situations. Now let's talk about why that is. Imagine that if you have a graph, and the graph has something like this, and I want to find slope at right here. I want to find the tangent line right there. Like this. I want to find this tangent line. Well, we're going to call this point C, and we're going to start with a secant line. So we're going to call this point of the x comma f of x, and this point is the c comma f of c. Now what I want to do is I'm going to start creating the secant line and approaching the x towards c. Eventually I find the sec tangent line of the green line. So if you go in towards that, if I shrink the x going towards c, so we're going to shrink the x going towards c. So we start with the secant is equal to y2 minus y1 like before. And we know that y2 is going to be f of x minus f of c over x minus c. Now we say what happened when x approaches c, so that's going to be the m of tangent is also known as f prime of c at f of limits as x approach c of f of x minus f of c over x minus c. So that's a reason how you get there. It's very similar idea than before, is that we assign a point a little bit different. The other time we said the bottom is h. Now we say it's x going towards c. And this is alternative form. Any questions? Mm-hmm.
Is that an M next to secant?
Yeah, that's a slope. Like m's represent slope. You know how m y equal to mx was for that m is represent slope. Now this is the equation. So we're gonna try to use this function. We're gonna find out the slope using this. So imagine if you have x squared minus 6x, and we want to says I want to find derivative is c is equal to 2. Yeah, c equal to 2. And we're going to use the definition of alternative derivative, which is what we're looking for. We're looking for what? You can try it for 30 seconds, and I will start 30 seconds. Just use this function here. See if you know how to use it. If you don't know, you can wait for me. I'm going to start in like 30 seconds. So let's say we want to find the slope at 2. So the way to denote that is going to be f prime of 2. Is that okay? Is limits as x approach 2 of x squared minus 6x, that's an f of x, minus f of 2. What's f of 2 again? What's f of 2? Which is what? Negative 8. Which is 8? 8 or negative 8? It's negative 8, right? So it'd be x squared minus 6x plus 8 over x minus 2. Now, if I plug in 2, it's going to be 0 over 0. So it'll be limits as x approach 2 of x minus 2 and x minus 4 over x minus 2. Is that okay? Now, if I plug in 2, what will happen? 2 minus 4 is going to be negative 2. So it gives you a particular slope at when x equal to 2, and it will be negative 2. Automatically give you a value. It doesn't give you an expression. As opposed to before, we give you an expression. Let's say we'll probably give you a negative 2x, and you can plug in any value there. But this time we can find out a value exactly at that particular point. Plug in 2.
Oh yeah.
And this is a few homework that you have to do here. Any questions?
Negative 8.
Because I plug in 2 into the function, it's f of 2. 2 squared minus 6 times 2 is equal to 4 minus 8, or 4 minus 12 is equal to negative 8. So I plug in negative 8. Any questions so far?
Why would we use the x to c if we could just do the other formula of derivative and then get the formula and then plug 2 into that?
You can, but this work is using for other purpose. For example, the absolute value. It will help you a little bit better because you can't really take a derivative of x absolute value, or like because there is no way for us to take a derivative of absolute value, and or even use definition of derivative. Or sometimes other situation this is actually more practical, and we're gonna talk about those situations. Now I want to talk about something that's always on AP exam. Is AP exam favorite is this idea is called I would say favorite. Anytime I say AP exam favorite, you have to know it completely. You can ask me question how this worked, but let's talk about differentiable. What does differentiable mean? Okay. Like I say, I actually help a lot of other teachers, that calculus teacher. So I will help like a calculus teacher from Cypress Creek. I'll help other teachers from different places. Because like in Miami, I also help another person using decimals. I like to help other teachers, but should say?
Because I said that's so self.
Oh no, I'm paying the butt. Actually, I got into argument with my my son's middle school math teacher 2 days ago. I write a principal.
Not in middle school anymore. Why are you arguing with his math?
No. I have two kids. He teach something completely wrong. I got really upset. I was like, I'm gonna take my kids out of this class because you're not willing to change even I'm trying to help you.
After you emailed, did they admit that they were wrong?
Yeah, the principal sent me an email, said the teacher acknowledged that she's wrong. But I don't care. Because like I don't respect that if you don't know how to do something, it's okay. Now I'm gonna tell you what's the right way, and if you don't believe me, fine. Then you gotta go research what is wrong. But if you don't go research, you just say you are right, as opposed of just say, I'm willing to look into it. What I did wrong, and that's like you're a shady teacher. I'm sorry, but if you're not willing to research what's wrong with you did or verify that you want, let's just say you want to prove that you're correct, that's fine. Then you gotta come up with a thing to verify that you're right. So limit exists is the first layer. And the limit exists is very easy, which is limit as x approach to a from the left of f of x is equal to limit x approach to a from the right of f of x. So that makes like this. In terms of graphing, it probably look like something like this. Longest if you approaching a is single point, even though it's open circle, the limit still exists. But we talked about this before. It's nothing new. This is continuous. We also talk about this. Can you tell me first condition to be continuous? F of A must define so that the point is going to be a solid dot at A. So this is a solid dot. Remember, we say it's defined. The second condition says limit x approach to A of f of x must exist. So it will look like something like this. It still exists, but is it continuous? No. So the third condition says limit at x approach to A of f of x equal to f of A. So I can move to where here? This is continuous. Questions? Now, what's the last one? Last one, this is all something that we knew about already. The last one is differentiable. What's differentiable means? Means limits as x approach a from the left of f prime of x equal to limits as x approach a from the positive of f prime of x.
Which do you have the limit approaching for number 2 on continuous?
Number 2, x approach to a. Okay, we're all using a here because so what does that mean? F prime of x. We know f prime of x is a slope, right? Slope on the left must equal the slope on the right. So the situation is like this. Not only is continuous, but slope at this point on the left end, let's just say the black line right here, on the left toward that particular point C, it has to equal to the red part approaching that. It has to be exactly the same. Slope cannot have a drastic change. Now, what do I mean by drastic change? For example, if I have a roller coaster going like this, right? It's a big, my hand like this, it's like this. Would you want to ride a roller coaster like this? Because you have a slope is 1 and the slope is 0, that's not okay. You want to make sure the slope is like, it's like connected like this. It's really connected and very smooth going from left to right. Okay. So it's continuous changing, not a drastic change. So some people say it doesn't understand what does that mean. For example, you measure rainfall. You measure in how high the rainfall is. The continuous data means the data is continuous growing. You don't grow from 1 centimeter to 2 centimeter at once, right? It doesn't make sense. You have block of waters drop all at once. It doesn't do like this. It does, it gradually increasing. And that's what happened. The gradually change of slope. It's not a drastic change of slope. Samuel, are you serious? Are you serious? What are you using phone for? This is a very important concept, and you want to sit there and using phone?
I was listening, but I'm sorry.
So the slope on the left side is equal to slope on the right side. Now imagine would you ride a roller coaster in this situation? Like probably not. And that's in like Phyllis and Ferb situations, right?
Yeah.
You can have a roller coaster look like this. This case, it will be out of track. It's something. This case is fine though. This case is completely smooth. You just turn, follow the wave and stuff like that. It's fine. Okay. So for me, that you have to understand this diagram. Now, why is this diagram is very important? Because if you understand differentiable is on top of the pyramid. If I say the function is differentiable, it automatically apply they must be continuous and limit must exist. It has to do that. It implies that if I say the function is differentiable. So on AP exam, sometimes they say the function is differentiable. You following on FRQ, you gotta write down says, well, if f of x is differentiable, implying it's continuous. However, if a function that they say the function is continuous, you cannot say that's differentiable because you only build onto this part of the pyramid. You don't have the top part of the pyramid. If it's continuous, does not imply it's differentiable, but the differentiable implies continuous. Okay, you must understand that order of hierarchy. So this is the highest hierarchy. If you have this, that means you have all the things on the bottom. If you have this, that doesn't mean you have this. Is that okay? That's understanding. Let's talk about 4 situations not differentiable. So 4 situation is not differentiable. So first situation is not continuous. Well, we already know that. If it's not differentiable, one situation is not continuous. How many situations not continuous? A, vertical asymptote. Two, jump. What do you mean by jump? For example, like the function looks like this. That's a jump. It's a piecewise function. C, a hole, which is that's all non-continuous. This is not even questioned because you don't have middle part of the pyramid. How do you form the top part? Two. The next one is sharp turn. Now, when you say sharp turn on AP exam, they don't give you credit, unfortunately. So how would you write it the sharp turn? But on AP exam, you can write this. You say limits as x approach a from the left of f prime of x does not equal to limit x approach to a from the positive side of f prime of x. That is means sharp turn. The sharp turn means slope from the left does not equal to slope from the right. Okay?
And so, on the graphic, that would look like the example you showed us of the roller coaster.
Yeah. Yeah. So this is a sharp turn, right? So for this differentiable, that means that automatically means slope from left equal to slope from right. So the black and red they are the same, so they must imply exactly the same. But if they equal each other, a sharp turn. It could be 0 to 1. It could be 1 to 1.5. That's still a sharp turn. Okay? Yes.
Didn't you say jump?
Jump is like this. This is a perfect example for jump, like piecewise function. They don't reach the same value. Okay. A sharp turn, it has two things. One situation is called a absolute value. So y equal to absolute value x minus 2. B, it could be a cusp. A cusp is a very interesting situation. Usually it's x to the even over odd power. Even over odd power. And we're going to give you an example that even over odd. So like say it's 2 over 3. X to the 2 over 3 is going to form a cusp.
Y equals absolute value
Minus 2. Okay, so 3. It's a vertical tangent. Now this one is really doesn't make sense in terms of analogy of roller coaster, because at roller coaster you get this situation all the time, and the vertical tangent occur at this point right here when the slope, when the cart is exactly perpendicular to the floor, and also at this point here too, right? This is called a vertical tangent because at that point slope is undefined. So if the slope is undefined, that means derivative is undefined as well. So slope is undefined. Or like infinity, for example. So slope is undefined. That's a vertical tangent. When it's a vertical tangent, it's not differentiable. Fourth, the endpoints. Endpoints not differentiable is pretty easy to understand because imagine that if you have a graph on the left or right, but the problem is I don't have a slope on the left of that endpoint, or I don't have a slope on the right from the other endpoint. So therefore, you cannot say that's differentiable. There'll be a few situations not differentiable. Does that make sense?
The circle, not the.
Yeah, it's not differentiable at the edge.
Well,
That's why you do an implicit derivative. When you do an implicit derivative, the first derivative, there's a y on the bottom. And when the y on the bottom is not, when y goes to 0, then that's not differentiable at that particular thing. It's negative x over y. So y is not, yeah. Yes.
So is it always on the slope is undefined or derivative must be?
Yeah. or like infinity. We're going to talk about both cases. So we're going to experiment with the definition alternative form because we cannot take the, imagine that if I have this function, right? F of x equal to absolute value x minus 2. I can really, like Andy was asking, can I just use definition of alternative, definition of derivative to get this? The problem is probably not, especially at x equal to 2. When I c is equal to 2. So we want to find out what is f prime of 2 is equal to question mark. Now we can find it two ways. One is geometrically understanding, which is a lot less work, which is what I want you to do on AP exam. Or I can prove to you that the other way. So first is to understand the graph. The graph is going to be this side. That's going to be x minus 2. The graph of this side is going to be negative x minus 2. Okay, so there are two different sides. On AP exam, that you want to recognize this, you can say, oh, I can figure out a slope. Slope of this side is what? M is equal to what? 1. You can say derivative when f prime of 3 is equal to 1. So this is f prime of 3 is equal to 1. Is that okay? Because you can tell the slope is 1. Geometric understanding. How about f prime of 0? F prime of 0 is right here. What is slope of that one point? Negative 1. And you can tell just like that, just like this. And you can also tell f prime of 2 is undefined. Why is undefined? Because it's sharp turn. If the sharp turn is not really defined. Herba, can you see? If you cannot see, I want you to move to forward. If you cannot see in the back, just let me know. I can change the C for you too. Is this okay? Now, I'm going to show you f prime 2 does not exist. I'm going to use the definition of alternative derivative. So I'm going to say limits as x approach 2 from the left. And if I approach 2 to the left, which function I'll be using? The x minus 2 or negative parenthesis x minus 2? Minus f of c. So c is at 2, so it's going to be 0. Is that okay? And the x minus 2. Is that okay? And that's equal to negative 1. We just proved that this is equal to negative 1 using definition of alternative form. We were not able to do that before. I mean, you probably can. Limit x approach 2 from the positive side. Then that's going to use the x minus 2. So on one side it's going to be 1, one side is negative 1. So therefore the left side is not equal to the right side. So therefore it's not differentiable. We just proved that's not differentiable. Yes.
Why would we get a zero? Like y minus 1?
Because it's f of x minus f of c. If I plug in c to the x minus 2, which is 2 minus 2, 2 minus 2 is going to be 0. Remember, f of x is equal to absolute value x minus 2. What's the f of 2? It's 2 minus 2 is equal to 0. So that's 0. There's a 0 after that. There's another situation. F of x equal to x to the 1/3. Let's show you x to the 1/3. X to the 1/3 is going to be like this. Do you see it's not differentiable at there? It's a vertical tangent, right? A vertical tangent is not differentiable. So at here is a vertical tangent. But we're going to prove to that we're using definition alternative form. So it's going to be limits as x approaches 0. Of f of x is x to the 1/3 minus, if I plug in 0, it's going to be 0, x to the minus 0. Okay. Then I can simplify this. Limit x approach 0 of x to the 1/3 over x is equal to limit x to the 0, x to the negative 2/3. If I simplify this, this is going to be 1 over x to the 2/3. Now imagine x is on the bottom, 1's on the top. If I have x approach 0 slowly, right? If I plug in small and smaller value on the bottom, the output eventually is going to become bigger and bigger and bigger. Does that make sense? Imagine if you plug in 1 over 0.1, 1 over 0.01, 1 over 0.00001. So this is 10, this is 1,000, this is a 1, like 10,000 or 100,000, whatever. So this eventually is going to go to infinite. If it goes to infinite, it will be does not exist. Yes.
And the values of C and is always going to be 0.
No, because we want to look at a f prime of 0. We want to plug in 0 here. If it's f prime of 2, then I'm going to plug in 2.
Okay. Actual order phrase.
Yeah, negative 2 over 3 and change to 1 over x to the 2/3. Yes. Yes.
Does that say 2 over 3 or 1?
2 over 3. Okay, so this is a vertical tangent situation. Yes.
Why is that negative? The
Because I do top minus bottom. So it'd be 1/3 minus 1. So 1/3 minus 1 is going to be negative 2/3. And I'll flip on the bottom because the negative exponent rules. Now I got infinite. Once I got infinite, then that's going to be undefined. Okay, so undefined. Because it's not really definable at infinity. That's why it's a lot of times when they say approach infinity, it does not exist. So that will be one thing. So it's undefined.
Where did infinity come from?
Huh?
Like, how did you get the infinity?
Because I'm approaching 0 on the bottom. Because I plug in very small value on the bottom. If I plug in very small value on the bottom, eventually it's going to go to infinite. Because we have small value 0.00. What if with 1,000 zeros? Then you're going to have 1,000 zero with a 1 in the front. So it's going to be a very, very big value. Now let's talk about x to the 2/3. That's the cusp. The even over odd power. It looks like this, right? Now, you look at this. There's two things. Sharp turn. Left slope does not equal right slope. But I also have something else. Vertical tangent. You see that the vertical tangent there? The slope is like exactly like this. If you do it to the 2/3, you're going to get the exact same thing. But here's the thing. I want to show you that the hard thing. If we just x 2/3 is the top part. Now, do you guys know what a square root r squared minus x squared graph look like? What is that? That's why the AP pre-calc is really bad, because AP pre-calc actually got through the whole section. They just axe it. It's called conic section. The conic sections talk about circle, ellipse, hyperbola, and parabola. So imagine that's a 4 minus x squared. You look at that's a circle, right? Like the semicircle, right? So basically, you see that red line is going like this. So imagine like I'm the cusp right in the middle, as if I have a head, right? So what happened is you bend those lines toward the semicircle, right? You bend it, okay? So what happened if you bend it? So x to the 2/3 plus, you see this part is the semicircle. You bend it toward a semicircle. Bend that line toward a semicircle. And then put a sine function in there to have a change your frequency of the thing. So it looks like this. So look at it. Take that thing and you bend it toward semicircle. And it becomes a heart. And that's what people come up with a heart symbol look like. Now the inside just a frequency. That's why a pi x, which is a is changing, move to bigger and smaller, and it will change the frequency of the wave. and eventually it's going to form like this, and which is pretty interesting. If you look at far enough, it looks like a beeping heart. It's actually pretty interesting. Now, we're going to talk about a power rule. How much time I have? 4 minutes? Okay. I'm going to talk about this very quickly because derivative of a constant is equal to what?
0.
Why do you know it's 0? Why is 0? We know it's 0, but why is 0? Because Peter Griffin tells me. Okay, why is 0? Do you know why it's 0? Yes. Max? It's not no slope. But you were right about constant. Imagine that y equal to 2. This space y equal to 2. What is slope of this line? Right? Slope is equal to 0. So imagine this is a 2. And slope is equal to 0. It's not just like coming from nowhere. Geometric understanding is really important. Okay. Now, what calculus told me there was a power rule. And which is this is going to be something that's very popular. Because from now on, you don't need to use definition of derivative anymore. If I take a derivative x to the n, all you got to do, it takes 3 seconds to explain this. Take the n, drop in the front. So it'd be n, x, and then n's going to be subtracting 1. But only apply when x to the n is on numerator. If it's a 1 over x to the n, does not work. 1 over x to the n, you have to change to x to the negative n, and put a negative n, so it'll be negative n x to the negative n plus 1. No, I will do that later.
Okay.
But imagine that you want to take this function, right? X to the q. What's the derivative of x to the q? 3x to the 3 minus 1, so it'll be 3x squared. Imagine before, you had to do this, right? X plus h to the third power minus x to the third power over h when limit x approaches to h approaches 0. So much work. So much work. But you got 3x squared. Now, we did that in like one line or even like half a line. Give me a second. Let me talk about the last part. If I take a derivative of this function, remember the function 6 over x squared? What's a 6 over square? It's on the quiz, right? And we're going to take a derivative of this. Now, I'm going to do an example for this one. Because f of x is equal to 6 over x squared, I cannot take a derivative when x squared is on the bottom. But I can make it move to the top. So how do I move to the top? Because this rule, exponent rule, says a to the negative n equal to 1 over a to the n, or 1 over a to the n equal to the second one, which is more important, which is a to the negative n. I can move to the top, becomes 6x to the what? Negative 2, right? Now I can take a derivative. If I take a derivative, I just focus on this part. I'm almost done. 6 times negative 2 times x to the negative 3. That's negative 12 over x cubed. See how easy that is.
Did you record it?
For what? Yeah. You had Emma and Lee, you guys got to watch the video. Very important video.
I don't know.